So now that we've got this method, this system for keeping track of the number of electrons on our different species, we've got this oxidation numbers. We can now start to think about what's going on to the electrons over the course of a chemical reaction. That's the whole reason we want to know these oxidation numbers. Now, a couple of reminders as we're thinking about our terms here. Oxidation is the loss of electrons or an electron or electrons. You're losing electrons. If you're losing a negative particle, so here we've got our neutral silver, it's losing one electron and becoming a 1 plus on its oxidation number. Oxidation results in the atom increasing its oxidation number. It's going to become more positive. If you lose negatives, you're going to become more positive. We see an increase in the positive charge on our species. Reduction, again, is the gaining of electrons. So here we've got our fluorine, our neutral fluorine is gaining this 1 electron to turn into our fluoride ion. We would say that it has gone from an oxidation number of 0 to 1 minus. Reduction results in the reducing or the decreasing of our oxidation number. I know we talked about this. It's just good to review it as we start to think about then our chemical reactions, because now we've got a method to figure out what's going on with the actual electrons, which don't normally show up or appear in our balanced chemical equations. So here's our reaction. We want to figure out for this reaction, which element is being oxidized, which element is being reduced. So in order to figure that out, the first thing we need to do is actually just go through and assign our oxidation numbers. And so we're going to go ahead and take a look here. We got copper. That's a pure element. Its oxidation number is going to be 0. Whoops. We don't need white. Let's do black. That's going to be easier. So oxidation number of 0 for our copper. Ooh. As we look at our silver nitrate here, we know our oxygen's a 2 minus. There's 3 of those. For a 6 negative altogether, for nitrate to be 1 minus left over, I think our nitrogen here has to be a 5 plus. That means our silver is a 1 plus. Just assigning our oxidation numbers. On the product side, we've got our silver. It's a neutral element, so its oxidation number is going to be 0 now. And we've got our nitrate. We've got a 2 minus there. We've got our, well, it stayed a nitrate, didn't it? Those got to stay the same if it's a nitrate. That leaves us with 2 negatives left over. This copper must now be a 2 plus for everything to balance up here. So I just went through and I assigned all my oxidation numbers. Our next step is to partner them up. So let's go ahead and take a look at what's going on here. We got our copper going from 0 to 2 plus. We've got our silver going from 1 plus to 0. All right, so let's think about what has to happen here. To go from 0 to 2 plus, our copper would have to lose 2 electrons. And up here on top, to go from a 1 plus to 0, our silver has gained, each of our silver has gained 1 electron, right? To go from 1 plus to 0, you got to gain an electron. So which element is oxidized? Well, oxidation is the loss of electron. We said that the copper was oxidized. Our silver was reduced. Here are our 2 species. This is a redox reaction. And now we know in what direction, who has lost the electrons, who has gained the electrons. And now we can start to figure out, okay, if we want to do something with these electrons, we need to start to get our electrons to go from copper to our silvers. It's going to be useful to us as we start to think about our kind of voltaic cells. Cool. Let's try one then from your handout. So as you look on the back of your handout, 21.1, I think this is the first one on the back there as we start to look at our balanced equations. Same process. First thing we should do is go through and assign our oxidation numbers. Well, pure element, that's a 0. Nitrogen, pure element, that's a 0 on oxidation numbers. Hydrogen is going to be 1 plus. There's 3 of those, so my nitrogen is a 3 minus. So if we're thinking about what's happening to the electrons here, we're going to buddy them up. Hydrogen's going from here to here. Nitrogen from here to here. For our hydrogen, we're going from 0 to 1 plus. In order to do that, you got to lose an electron. To go from 0 to 3 minus, you got to gain 3 electrons, right? For that nitrogen to go from 0 to 3 minus. Cool. So then if we want to know who was oxidized, well, who lost? We would say that our hydrogen was oxidized. Our nitrogen has been reduced. this is a redox reaction. We have seen a change in the charge on our oxidation states. Cool, armed with these examples, hopefully you should be able to finish the back of 21.1. If you got questions, feel free to reach out. We can Zoom, we can email. You let me know how best to support you. Come with questions when I see you again.